Math 3, Unit 9, Section 6. Today we're just doing Part A, which on your homework, it's questions 1 through 10. Our cell phones are put away and we are focused. Wonderful. Okay, so today, there isn't really anything new that we are learning. We are just putting two things we have learned together. Okay, so we have learned how to solve log equations. Now we are going to use our condensing and expanding in order to solve the equations. Okay, your log rules are right here to remember them. And you can go through and read these instructions, but we're just going to go straight to doing the problems. Okay, so first example. The first thing I noticed, you guys remember back when solving log equations that if we had a single log on both sides, that we could cancel them out. Yes? Okay, the issue here though is that right now there's a 2 in front of this log, which you can't have. They have to just be a log. Okay, you can't have a number in front. So is there any strategy or things that we know that we could do in order to get rid of that 2 in front? Exactly, we move it to the exponent, correct? Okay, so we're going to go ahead and move that to the exponent so that goes away. I'm going to rewrite this now as log base 6 of x over 7 equals log base 6, and we simplify that, and 3 squared is what? 9. Okay, now do I have a single log on both sides? Yes, so I can cancel them out, and we have our problem of x over 7 equals 9. And what would I do to solve that? Very good. Multiply by 7 to both sides, and we have x equals, and 9 times 7 is? 63. Well done. You want to always make sure you can most of the time kind of just look back at the answers. Make sure that it would make a true statement. Because remember, in this spot, we can't have a negative number. It won't work. But 63, it's not going to make any kind of negative number. But there are some problems that you could get a no solution because you get a negative here. And if you were to plug it in, it wouldn't actually work. Okay? All right, so let's move to the next one. Again, I don't have a single log right now on both sides in order to eliminate the logs. So we need to somehow condense, move things around so that we get a single log on both sides and can solve the problem. So on the left side of the equation, what's the one thing that I need to do? Very good. Move this 2 to be the exponent. And so I would get log of x to the second power. Everybody okay with that part on the left? Okay, now on the right side, we don't want the 6 there, correct? And so what do I do? We're going to move this to the exponent as well, making that 2 to the 6. So I have log of 2 to the 6 minus log 4. Okay? And you can multiply out 2 to the 6 before you write it down. It's up to you. But again, do I have a single log right now on both sides? Right, I have 2 right here, right? Do you guys see that? I need just a single log on both sides in order to eliminate them. So I need to use, we are going to condense them. Because these are both the same type of logs, so I can put them together, correct? We can condense them. All right, so on the left side, I still have log x squared equals, and over here, first of all, 2 to the 6th power is what? 64 is correct. 2 to the 5th is 32, and then multiply by another 2, and I get 64. And so when I condense this, okay, we know this is 64. What happens when you're subtracting? How do I write that? Very good. 64 over 4. And can I reduce 64 over 4? You are correct. They do both have 4s on them. Okay. Exactly. And even at this point right now, do you see I have a single log on both sides? Yeah. So now I can cancel them. You can't do that until you have one log on both sides of the equal sign. And so my problem now I have is, oops, pretend I didn't write that. X squared equals, and what's 64 divided by 4? 16. You just were one step ahead of me. 16. And then in order to get x, we would take the, very good, square root of both sides. And x equals 4. 4 is correct. Now, normally, when we take the square root, we would have positive and negative 4. Okay? But I can't have a negative 4 in this spot. And so 4 works, negative 4 does not, and so my answer is just 4. Do we have any questions on that? No. Okay. So what are we going to do on this next problem right here? I'm going to make this bigger. Okay, focus. All right. This is not a single natural log on both sides. There are 2 right here. So we need to do what to them? Condense them. Very good. Now, when we condense, when there is a subtraction sign in here, that means I'm going to change it to what? Division. So when I condense this, we get natural log 3x plus 5 over 7x plus 2 equals natural log of 2. Is there now a single log on both sides? Yes. Bless you. These eliminate or reduce, cancel, however you want to say it. Okay? And my problem now is 3x plus 5 over 7x plus 2 equals 2. How do I get rid of the fraction like that? Yeah. So we're going to multiply by our common denominator, whatever it be. So I'm multiplying by 7x plus 2 to both sides. When I do that, the 7x plus 2 cancels out. I have 3x plus 5 here on the left equals, very good, 14x plus 4. Then we do what? Okay, subtract 3x to both sides. And at the same time, we could go ahead and, I would subtract 4. Just because you want to get your plain numbers on one side and your letters on the other. We don't want this one set equal to 0. The ones we want set equal to 0 is if you have a squared term and we have to factor. Okay? So this we're just solving. 5 minus 4 is 1. 14x minus 3x is 11x. And then we would divide by 11. And my final answer is x equals 1 over 11. Now, always double check. If I were to plug this in, is it going to give me a negative answer right here? No. And it's not going to give me a negative answer here. So it works. We're good. Any questions? Okay, moving on. What is so nice about this problem? It's already done, like in terms of you have a single log on both sides. So what can I do? Very good. Cancel out those logs. And so my problem is 2 to the 3x equals 32. Now, what do you guys remember about this? How can we solve this? Yeah, you want the same base. Very good. And so I'm like, can I change 32 to be base 2? Yeah. So 32 is what? Good. So I have 2 to the 3x equals 2 to the 5th power. Since I have like bases, what can I do? Very good. Cancel out the bases and we get 3x equals 5. And then the last step there would be to divide by 3 and x equals 5 over 3. And again, just make sure it's not going to make any negative numbers. And if I plug that back in, it will not make a negative. And actually, we can have a negative exponent. So, okay. So far, so good? Okay. 2 problems left we're going to go through. What do you notice on this one? There's 2 logs. 2 logs. Therefore, we're going to have to condense. Very good. And how do I condense? Squish them together. We squish them together. Very good. And because it's adding, when we squish them together, multiply. So we have log base 8 of x times x minus 6 equals log base 8 of 7. Now that condensing now, what can I do? Yeah, we will distribute the x, but before that, because we have them a single log on both sides, we can? Very good. So we will cancel that out. Now, we're going to distribute. Are we okay with that?
X squared.
We get x times x, which is x squared. And then we get
Minus 6x.
minus 6x equals 7. Now, this has an x squared term, which means we need to have it set equal to 0. And so therefore I would,
Subtract 7.
well done, subtract 7. Good. X squared minus 6x minus 7 equals 0. How do I factor?
Oh my god. You add and multiply.
Very good. You always add and multiply. Multiplying number, adding number. What's my multiplying number?
7.
Negative 7. What's my adding number?
-6.
Negative 6. What numbers will work?
1 and 7.
1 and 7.
Okay, 1 and 7. And specifically, negative 7. So when we multiply these two numbers, they make negative 7. When we add them, they make negative 6. We just figured out the puzzle. Okay, so we write that as x plus 1, x minus 7 equals 0. And we set each of those equal to 0, and we get x equals negative 1, and x equals 7. And just like before, I said always go back and check to see if it'll make, if you get a negative number in that spot, it won't work. So if I were to take negative 1 and put it right here, that would not work. That is not one of the answers. 7 though will not give me any negative numbers. So my only answer is just x equals 7. Any questions? Okay, last one.
There's 2 logs.
There's 2 logs, which means we need to condense. Well done. Because this has subtraction, when we condense, it will become, well done. So I will write this as
Log
Base 2.
2
5x minus
5x minus 4.
well done. Log base 2 of 5x minus 4 over x equals, and here that's a single log, so I'm just going to rewrite that, log base 2 of 3. Now, what's my next step? Very good. Because we have the single log, we can eliminate them, cancel them out. My problem now reads as 5x minus 4 over x equals 3. Because I have a fraction, we want to eliminate the fractions. How will I eliminate the fraction?
Multiply by x.
Well done. Multiply by x. When I do that now, the x's eliminate. We have 5x minus 4 equals 3x. Next we will.
Subtract 3x.
You could, I would subtract 5x because it'll just give me less work, but it's not wrong to do it. This way I get all the x's on one side, so I have negative 4 equals, and 3 minus 5 makes negative 2x, and then I can just divide by negative 2 to both sides, and x equals 2. And when I double check, 2 will work here, 2 will work here, it won't give me a negative, and that is my answer.